First sample problem, the sample says that I have a vat of 60% of carbon, 13.4% of hydrogen, and 26.6% of oxygen by mass. Somebody went and analyzed this and came up with these answers and wrote this down and sent it to our class to solve the problem. And so with carbon, hydrogen, and oxygen, I know that my empirical formula is going to look something like CHO. And I don't know what the sub numbers are going to be. That's what I'm going to calculate. So number one, we want to assume that the vat of this stuff weighs 100 grams. It doesn't matter what it weighs, but since we have the percentages, I want to work with something where I can get some grams, some masses, and then we can calculate how many moles there are. Okay. And you recall, if I have 60% of carbon, I'm going to say that's the same as 60 grams of carbon, since they got to add up to 100. And I have 13.4 grams of hydrogen. Before I had 13.4%, and then I'm going to have 26.6 grams of oxygen. If I add this up, it adds up to 100, and if I add these up, it adds up to 100 also. So I have to look up my atomic mass units of carbon, hydrogen, and oxygen. We've been looking this up so much we probably have it memorized by now. But 1 mole of carbon weighs 12.01 grams, right? 1 mole of hydrogen weighs 1.008 grams, and 1 mole of oxygen has a mass of 16.00. So now I can take my 60 grams and convert it into, using my model, I can convert it into the number of moles, right? I have to use a conversion factor. And I'm going to go from grams to moles, and so I need my my conversion factor. So I'm going grams to moles, so I need moles on the top and grams on the bottom. So I look up my AMU, I put it on the bottom, and here's my grams, and I multiply this out, and I end up with 60 divided by 12, right? I'm multiplying this. You could look at this as, some of you have difficulty with this, 60 over 1, right? So the top numbers multiply, and so I get 60 divided by 12, so 5 divided by 5, that's it, 5. This is later, this comes later. Okay, 1.66. Let me erase that, 1.66 so we don't get confused. Okay, this is later in the program. Okay, so I've got 5 moles of carbon. And so I'm going to do the same thing with my hydrogen. I got 13.4 grams of hydrogen, and my atomic mass units is 1.008. That gives me 13.3 moles of hydrogen. Okay, never mind that. We'll do that later too. And then finally I have 26.6 grams of oxygen divided by 16, and I end up with 1.66 moles of oxygen. And once I get to this point, I think our step number 3 on the previous lesson was that I've got to get these down to units that are single units and so forth. And the easiest way to do this to start off with is to divide each one of these by the 1.66. This is where the 1.66 comes in. And each one gets divided by that smallest unit. Okay, that ensures that I end up with at least one of these answers will be equal to 1. My sub number will be 1. And as it turns out, these all come out pretty close to an even unit. So this hydrogen comes out to 8. My carbon comes out to 3. So these are going to be put into my empirical formula up here. And so my carbon is 3, this is carbon, that's 3. Hydrogen, I'm going to have 8 hydrogen, and I'm going to have 1 oxygen. So this is my empirical formula for this vat of unknown stuff. well, it's known stuff, but different quantities. And that's typical, so let's see if we can do one more problem on our homework assignment. I'll do that next, and then you can continue and do the rest.